it hallucinates less. You can attach your own files, your audio files, video files, PDF files, Word files, and then it can again ground your answers in the documents you upload to it. You can use it in the voice mode if you click on this mic icon, and you can speak with it. Let's look at the right-hand side panel. You can see assistant over here. This assistant is the AI agent that you can use. For example, you can ask it, show me the cheapest flights to Delhi from Bangalore tomorrow. So for this, it not only needs to search the web, it also needs to analyze what is on the websites, and then it needs to identify which is the cheapest flight, right? So it once you do this, you will see it's giving you the analysis, which sites are there, and what is the range of fare tomorrow between Bangalore and Delhi. These are the important sites: Ease My Trip, Make My Trip, Go Ibibo, and all that. And then it has identified something. So you can also tell it to go and find me a site, go and find me a ticket. Once you get results, please share on the chat window and let's see whether we are on the same page or not. Ask it to book a ticket for you for tomorrow from the place you are at now at present to some place, and see how the results are being generated. Like it's showing you what it is doing, what reasoning it is using, how it is proceeding to next step. This is a step-by-step proceeding based on reasoning at each step. I hope those who have access to Comet browser are doing this along with me, right? So see, I can see you're already on Make My Trip with flights from Bangalore to Delhi. I need to select August 5. So it knows that today is 4th and tomorrow is 5th August. It's also looking for departure date, right? It noticed that date is 4th August, so it needs to correct the date, right? It's giving an evaluation to itself. Perfect. I can see that the date has been updated. So it's doing the actions. It's calling the API from makemytrip.com. It's updating the fields like to date, from day, to place, from place, date, place, and everything. See, it has come back with the result. I have found the cheapest flight tickets from Bangalore to Delhi for tomorrow. And here is the option that it is giving me. The low priced option is 6,027 rupees in Indigo and all that. It has done complete task for me. I only now have to open that site and make the payment. If you connect your Make My Trip accounts with Perplexity, it can also book your site and make your payments if you're connecting your wallets with this browser, right? You can also speak with it if you click on this mic icon, and you can have a wonderful conversation with Comet browser. This is a very simple example. I won't say simple, but this is a fantastic example of what an AI agent can do. It is very different from what you used to do with Google. If you try to search for cheapest flights in Google, it will show you a list, right? But it won't go and find the lowest priced option. It won't go and book the ticket for you, make the payments and everything. On the similar lines, you can ask a browser like this to go and shop for you at Amazon.in or some other web commerce site. Put the articles in your cart, make the payment, and even get them delivered to your house if you want. So I want some inputs here from participants. Have you observed? What did you find? Just put it in the chat window. Well, did you use? Yeah. How can you help? Great. So, what did you notice? Did you use the browser, the Comet browser? Yeah, those who do not have access, it's okay, but those who have, mm, it's actually performing the tasks exactly. It has the ability to call API of MakeMyTrip.com or Google Calendar API, Gmail API. It can even look at your Gmail account or any mail account. It can summarize your emails. It can identify whether any of the emails is a meeting invite or an important reminder is in an email. It can then remind you that that person in that email asked you to come and meet them at that place. You should go there. Yes, Perplexity Pro is available for free if you are using Airtel. I am opening my presentation back. So we saw the agentic browser Comet hands-on in demo. Now let's dive into more depth of its technicalities. We'll look at the components typically agent system has. So here is the breakdown of components of an AI agent. At the center, at the heart, or at the brain of AI agent is an LLM, a powerful reasoning LLM. This LLM is capable of understanding the task or the query or the prompt you give it. It can split that task into subtasks. It can generate the sequence of steps it requires to perform in order to achieve your goal, achieve your task, and so on. But that is not enough. It also has access to tools. By tools, I mean a set of APIs or function calls that it can make. And through these APIs or function calls, it can access databases, it can access the utilities provided by other websites, as we saw Make My Trip, similarly Google Calendar, Gmail, Wikipedia, and so on. The other thing that an AI agent has is memory because typically LLMs are stateless. They do not save your previous interactions. When we add memory to them, they are able to save context, they are able to save your data information or previous chats you've had with them. So an AI agent has memory in which it stores your recent chats and it stores the system prompts and it stores something else which it thinks is important to remember. In addition to these three very important components, an LLM, tools, and memory, it also has a prompt template. Prompt template usually is the system prompt for that agent. And this prompt template tells the agent how to behave. It sets the behavior for this agent. So you should always follow the principles of prompt engineering. We will see it in depth later, but there's a prompt template. And on top of this, there's an orchestrator or a supervisor, which is called an execution engine. Execution engine is in charge of running this agent in a continuous loop. So it invokes the LLM, it manages the call to tools, and it manages the interaction with memory and so on. And all of this is set in motion by a user. Generally, a human user asks for a task and then this agent's loop gets into action. But it's not necessary that always user is to be a human. It can be another agent or it can be another AI system also which can invoke an agent. This is usually in case of multi-agent systems. A team of agents works collaboratively and they invoke each other, they call each other. In addition to these absolutely important components, sometimes there may be guardrails. I mean, often there are guardrails also. Guardrails are a part of system prompt which prevent your agent from behaving in a harmful manner or in an undesired manner. Similarly, there is sometimes voice agents, they have voice specific capabilities. There are audio and speech agents, they have that specific capability, and so on. In some agents, there is memory that is used for prompt caching. Prompt caching is storing information for long-term remembering and recall. This allows you to get responses very quickly. It reduces the latency, which often is observed while accessing an LLM online through internet. As I said, tools are function calls, and you specify what tools are available to your agent in the form of a JSON or XML file often. And it's absolutely important to follow a strict and correct format when you are specifying which tools are available to your agent. Your tools must be correctly configured and so on. We will see all of this in detail with examples today also and in coming sessions also. Then planning, and we spoke about the ability of LLMs to reason and plan and use tools and so on. So what is kind of the difference between reasoning and planning? So reasoning is understanding, trying to understand what you or what a user wants an LLM, an agent to do, splitting that reasoning into steps and trying to validate that these steps actually will lead to the correct outcome. Planning, on the other hand, is deciding what steps to take, and a sequence of steps to take in order to achieve a goal. All right, so that's the difference between reasoning and planning. You do reasoning and then you decide what to do, and that list of to-do steps is called a plan. In this slide, you see that there's a robot that is planning to clean a room. So the plan may look like go to room A, then pick up the trash, then vacuum the floor, then go to room B and repeat the steps. So this is the plan. These are set of actions that the robot plans to take. On the other hand, the reasoning will be like this. While it's planning to vacuum the room, it has to reason something like this. If the floor in that room is wet, vacuum could get, it can get damaged. So I should either dry the room first or I should skip this room. I should not vacuum this room. So that is reasoning. And with the concrete reasoning, it decides the action to take, and that sequence of actions becomes a plan. Here are a common set of tools. This is by no way the exhaustive list. These are just few tools which are very commonly used. We can access archive, which has the set of research papers. You can access AlphaVantage, then AWS's serverless hosting platform Lambda. You can use your command prompt, your shell. You can access Google and Big Search. You can use your local file system. You can use Gradio through an agent. You can also have human in the loop. You can access PubMed and SQL database, PostgreSQL, Supabase. You can access Wikipedia, then Twilio, and of course YouTube. And there are many more. All these tools, all these platforms have their APIs, which they expose, and LLMs in an agent it can hook up, can bind with these APIs and call them in a workflow. Now let's disambiguate some terms which we hear all the time, and sometimes we are confused about how they are different and what do they exactly mean. A chatbot or an AI chatbot is a software system that you can converse with. You ask it questions, it can only give you answers either in spoken or in written format, in natural language. Then there is something called an AI assistant. An AI assistant is not just chatting, it can also perform tasks like we just saw Comet browser. It can analyze your information, it can analyze data, it has memory, it can do things for you by calling tools. Then there is AI agent. Now, AI agent is completely autonomous. A lot of times it runs in a continuous loop. It can sometimes set its own goal, or the human user can give it a goal, but a lot of times it can also set its own goal. Then it can plan a sequence of actions and it can execute those actions, often in a loop. There's another term called workflows. We often have systems for workflow automation. So workflows are systems where LLMs are there and tools are also there, and these LLMs and call these tools and access memory in a predefined sequence of steps. There is often not an adaptive or dynamic component to workflows. They're like flow charts, right? First, this thing will happen, then this thing will happen, then this thing will happen, and stop. So the difference between a workflow and AI agent is in terms of dynamism. While an AI agent can be unpredictable, it can decide, choose a different path every time it goes for the same goal. A workflow is a fixed set of steps that are often followed by the LLM in a system. With that, we are moving to AI agent architectures. Do we have any questions so far? If there are any questions, let's
Hello, ma'am.
I have one question.
yes.
Uh, go ahead. Actually, I'll ask later.
You can ask now, sir, if it's okay.
Hello.
Okay, I can ask because the other
Huh,
side.
huh,
So, yeah, hope you're able to hear. See,
huh,
what
I
is the
can.
difference between assistant and agent? Exactly, what is it that is it just the autonomy or something else in agent over
Uh,
assistant?
Autonomy is the first factor. Another factor is the loop. AI assistant will often get a request, perform it, and stop. But agent more or less will be working in a loop continuously, doing one task or the other for you. And when it's not there, it's also doing the action of waiting. When it's not doing achieving a goal, it's waiting, which also is a sequence. It's a flow step in its loop.
Okay, got it. Thank you.
Are there any other questions? We can also
I
put
I
them on
have a
the chat.
question, ma'am. Yeah,
Yeah,
hi.
please.
Am I
Hi.
audible?
Yes, you are.
Yeah, thank you, ma'am. And actually, this you said that we can even book flight tickets and we
Yes.
can do the payments and all that. But how, is that reliable in terms of payment options? Like if we give the
A
AI
great
to,
question. Great question. See, tools like Comet and other general purpose tools, you may have an issue with trusting whether should you give them access to your wallet, your Paytm wallet, or your Google Pay wallet or not. But there are certain financial agents which are meant especially for handling finances. So they have inbuilt security. You can trust them. They are
okay.
specially built for handling your money, right? But of course, not the general purpose browser like Comet.
Okay.
A great
And
question.
we will see when we write a code for agentic AI, that
Hmm.
time we will we code like to call some other apps and how it will work?
Yes,
Are we going to
yes,
see that?
yes, yes. Not today.
Okay.
On session 3, we will see it in code. In session 4, we'll see it in no code. Both what are different tools available to your agents normally, how to connect them, what things to keep in mind while connecting, and what can go bad. Everything. We'll have a look at
Okay.
them.
Okay. I'm looking forward to it. Thank you.
Sure, sure, sure. Are there any questions? Are workflows similar to agile orchestration? Yes, they are. Yes, they are.
am I audible?
Yes, yes.
I'm audible now?
Yeah, you are.
Yes. I wanted to ask one question. Let's say we give an AI agent some task and it like describes a set of steps to do it.
Hmm.
And legitimately, it's possible that it can, loop through specific like steps of tasks. But what if it's ended up making some wrong decisions and just looping indefinitely through the
Oh,
steps?
absolutely, absolutely. If you're, we know that these LLMs can hallucinate, right? And it's an LLM which is generating the setup steps that the agent needs to take. So there absolutely is a chance for that. But then the agent developers and teams put in guardrails and evaluations where if the results seem risky or threatening or wrong, then the agent will be stopped from proceeding further. And there are prompting techniques, there are agent architectures that we are going to look ahead, where these things are built into the agent design. If the results don't look trustworthy, if the results look inaccurate, stop or go back and generate a new reasoning trail. We will see a chain of thought reasoning, we'll see react reasoning, we'll see tree of thought reasoning, we'll see reflection mechanism where the agent is reflecting on its own reasoning trace, its own plan. It's trying to evaluate and cross-validate it. This is one thing. In multi-agent systems, there are specialized LLM agents which are in charge of this evaluation of other agents. And
Got
so
it, ma'am.
there
Thank you very
are,
much.
yeah.
Good
And
evening,
one
ma'am.
question.
Yes, 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 yes. Yes, please.
Like actually we were having this agents probably from 1990 or some 80, but since these LLMs have come, this AI agent architecture has become very popular. Is
Right.
it that, madam? And one more thing, since you are using LLM for reasoning, as the other ma'am asked, suppose if there is some hallucination, then how do I rectify the AI agent?
Correct. The answer to your first question, that AI agents have been there since a long time. I guess that book came in 1990s, the Richard Sutton book, and he introduced RL agents. So the concept of automation is a long one. That's correct. But those RL agents used an algorithm, a learning algorithm, and it was not adaptive, right? It didn't change if your environment changed very frequently. But this LLM based learning of or deciding what to do given the user's prompt is changing because LLM is also being continuously trained based on new interactions, based on new experiences and everything. That's the difference between the agents or automation that we have seen previously and the automation that we are seeing in AI, LLM based agents. Did I answer your question? First question?
First question, my
Yes,
second question
yes,
is,
yes.
since
I
you
am
are
about to
putting the
answer that. Yeah.
uh,
Your second question is about reliability, right? Or
yeah,
robustness of the output.
reliability for reasoning of
Correct.
LLM.
Correct. So if your task is tough, it is a multi-step task. It's a complex problem that you are asking an LLM-based agent to solve. And this agent is not meant for that kind of reasoning, that kind of solving that problem, then it will fail and your result will be wrong. And of course, the final responsibility of validating, verifying is on on a human user. Having said that, the LLMs that these agents use are very strong reasoning models. It's not a normal text generator model. These are reasoning models. They are capable of generating reasonings for almost all tasks that they have been trained on during their pre-training sessions, right? So for a lot of tasks that we humans normally do, they have seen them during the training and the results have been correct. But definitely there are chances that for some complex, complicated, multi-step task, long task, they may fail. And in such cases, there is a possibility of having human in the loop. That human in the loop often gives nudges to the agent. The human gives inputs, and through prompts, the human directs the agent not to select a path which seems risky or murky and choose a different path. Did I answer your second question, ma'am?
Yeah, but the problem is, uh, suppose we are using some normal models, they are not fine-tuned for our specific task.
Like these LLMs, the
Yeah,
foundational
yeah, yeah.
models, they
Then we
like
need to fine-tune them for our particular model and then only apply them for this, for our use case. Is it okay,
can you
ma'am?
give me an yeah, yeah, sort of okay. Can you give
Suppose
me
I
an
want to
example?
use it in, say, some medical, some hospital where everything is automated, like from the billing to the OPD reservation of slots. Then I've got multi agents. Then
Correct.
how do I say my normal LLM of OpenAI will react to it?
Very
Because then
correct.
I need to
Very,
fine
very
tune it.
Yeah, yeah, that's a very valid question. Suppose this is a domain specific task. You are assistant to a doctor, a surgeon, or you are assistant to a lawyer, or you are an assistant to somebody working in banking and accounts, right? So a general purpose LLM will not be correct. You require to fine tune. The reasoning models, for example, in case of medical domain, there are specialized models created by companies like Google and other companies. They have already been fine-tuned on medical use cases, right? And while building
Yeah.
your agent, you can choose that LLM to act as its brain. Instead of normal GPT 3.5 or GPT 4, you can use that model, MedGamma, or some else model, which has been fine-tuned, right? If this
Can you
also does
name
not,
what is that, ma'am?
MedGamma,
MEDGAMA.
yes, ma'am. And if
Okay.
that also does not look good, if it is not giving you the desired answers, then of course you can fine tune your own model. If this is a very niche use case, you're working on a very, very rare disease, which is not, which has not been already trained on, then you can do a very small layer of fine tuning and then use that model as your agent's brain.
Thank you, ma'am.
Can we set accuracy or precision percentages for guardrails to safeguard the results coming from AI? We can set guardrails, and guardrails are often rules on what to generate, what not to generate. You can also set a threshold on accuracy or precision, but accuracy and precision are generally used to measure classification results, right? The metrics used to evaluate these models are a bit different. In a later lecture, we'll actually look at the evaluation, the benchmarks, and we'll see how these models are evaluated. But yeah, guardrails are definitely used to safeguard that the results are accurate and they are reliable. Can there be multiple agents connected together to execute certain tasks? Of course, there are multi-agent systems. They work as a team, a coding team, a research team. We will see in coming lectures. You can use RAG, definitely. You can use RAG, which means you can upload your own documents and your model, your LLM will refer to those documents before generating any reasoning trace or before generating a plan. I have a very fundamental question. What is the difference between pre-training and post-training? So pre-training is when a company makes a large language model from scratch. It collects data from all over the internet or companies or proprietary data, and it runs algorithm. Generally, the training algorithm for transformer model, it is often done on thousands of GPUs for months or for weeks together, and the transformer model learns its weights. It's called pre-training. After the pre-training is over, this model is capable of generating the next word if it is a text model, if or it is capable of generating next pixel in an image if it's an image model. This is what a pre-trained model can do. Then during post-training, they train this pre-trained model using supervised learning. And during this supervised learning, they show it the input. For example, they show it the images of cats and corresponding label cat, and it learns to associate the pixels with the label cat, or they can give it some questions and answers, and the text generator pre-trained model learns to understand questions and generate answers. So that happens during post-training. Post-training is not as resource intensive as is the pre-training. Like pre-training is when a student has its education in classes 1 to 12, that is pre-training. Then post-training is like specialized training, engineering or medicine or law. So that is post-training, specialization. Does that answer your question? Is there a way to measure the extent of pre-training or training? I don't know if I understand that question well, but when for example, when your text model is performing right on benchmarks of generating the next word correctly, then it is said to be sufficiently pre-trained, or it has, or the amount of data set you are using is good enough. It's said to be pre-trained properly. You have used enough time, enough compute, enough data, and your model is good, then the pre-training is sufficient. Right.
Can
Yeah.
I can I
Yes. Yes.
can I listen? Thank you so much.
Yes.
So I was the one asking about the pre-training and the training part.
Yeah. Yeah. Yeah.
So actually, it might be possible that some models are, let's say, there is a data set, and I have
Right.
done some amount of pre-training and some amount of training on that model.
Post-training, right?
Now, post-training, right?
Huh.
Now, if there is a way of measuring it, then maybe I
What
could
do
have
you mean
two
by
models.
measuring? What
Yeah,
do you
so
mean by
that's what,
measuring?
right? I'm not being able to put that into words, probably. Maybe measuring would be not a appropriate word. What I mean to say is that, let's say that the student who has
Measuring the
studied up to class
accuracy
10,
by some metrics.
Yeah, probably that is what sir
probably,
wants
yeah,
to.
maybe accuracy or maybe the
Evaluation
precision
might be
or
the
maybe,
word.
Yeah, evaluation. Yeah.
yeah,
So
maybe.
I understand what you're
Yeah,
asking.
so I
So
mean,
if
I
I'm
could have two different models, right?
hmm,
In
hmm,
one of them, I would intentionally pre-train less and train more. post-train mode. So, for example, there was an example which came about the rare disease. So, for that, I would pre-train less on all the rare diseases, and on a specific rare disease, I would post-train more. Whereas, let's say I'm talking about breast cancer specifically. So, on cancer, I'll be training completely. Then, on post-training, I'd be specifically training about the breast cancer. So, is this a good way of creating models?
Yes and no. So during pre-training, yes, you will be showing your model. You will be exposing your model to a lot of images of different kinds of cancers and not cancers and everything else. General data set of images. This is pre-training. And what happens during pre-training? The model learns to recognize the relationships in data. For example, it learns to recognize edges and borders and segments and all of that. That is what it learns, the vocabulary of your data set during the pre-training, right?
Right, exactly.
And
So
during
when it comes to
post-training,
breast
yeah,
cancer,
during
during
post-training,
breast
it
cancer
puts that vocabulary to use for your specific,
for a
like breast
specific,
cancer data set.
correct. Now, when it is about rare disease, and let's say I'm
Hmm.
working on genomic data,
Hmm.
so all rare diseases have certain genomic signature, but
Correct.
specific rare diseases have like very specific genetic signature, a genomic signature,
Correct.
epigenomic signature.
Correct.
So
Correct.
maybe the pre-training would be a little less. I would not do as much pre-training as I was doing with the cancer, non-cancer images. And
Correct.
then I would specifically do a lot more post-training on the specific rare genome, rare disease. So is that it? Is that, I mean, can I
No.
look at pre-training
No.
and post-training this way?
No. The first answer, the straight answer, TLDR is no. Unless you have done sufficient amount of pre-training, your model does not post-train well, right?
Okay,
If I am
understood.
to give you an analogy, a student who has not cleared standards 1 to 12, who has not learned mathematics, will not do well in engineering. It's like that. Another thing that I
Yeah,
want
but
to add
a
here
student
is
who has maybe passed all the classes, maybe that student would be good in music. So after class 12, that student might go for music. But even when the student is reading music sheets, he might require some knowledge of, what are parallel
at
lines,
least
what
the
are
student needs to know how to read well, right? How to understand
correct,
well.
correct, exactly. So certain amount of pre-training is required, but if I can maybe create a benchmark for that, saying that okay, this much
Correct.
pre-training. Once I've reached this much pre-training, then I can proceed to post-training, which
Correct.
constitutes the more part of it.
Correct. There is one more thing I want to say here. The models which are used for genomic sequences and tasks like bioinformatics specific things, those models are not trained on text or images. They are trained on genomic sequences. You might have heard about
Right.
Google's AlphaFold, right? The model which can
Yes.
predict protein structures. It is trained on protein structures, right? It's not trained on text. So those models are trained on that kind of data. Their pre-training happens on that kind of data. So I think we will go back to the slides and we will take questions either offline, you can DM me, or of course, I mean, we can do it tomorrow also. Is that fine?
Sure. Thank you so much.
Madam, good
हाँ
evening.
sir, हाँ good
I
evening.
have a small doubt,
हाँ
like about validation.
हाँ.
The validation is going to be an implicit in the model LLM, or it is going to be taken care by some other code which is to be generated by the developer during
A
the
lot
process.
of yeah, a lot of validation or self-correction, self-criticism is part of the model structure, the way model works. Model's agent loop consists of that self-reflection, self-criticism, and self-correction. A lot of it. But there still can be some cases where an external human validator is made available. It is especially true of high stakes use cases like medicine, law, or finance, where somebody's life is at stake.
Then how about conflicts, madam? If any conflicts occur, then how about those conflicts?
That is a area which is called AI governance. So you have a committee in place who decides what to do, whose responsibility is it if somebody dies, or let's say an or self-driving car hits a passenger, who is responsible? Is the software developer responsible? Is Elon Musk responsible? Who is responsible? So that's AI governance. That's a complete field in itself.
Okay, okay, madam. Thank you so
Yeah,
much.
yeah. So let's quickly move back to agent architectures. There are a few prominent architectures like chain of thought agents, reasoning and acting agents, reflection agents. Then there is tool former agent and Voyager agent. These agents actually make sure that whatever they reason, whatever they plan, that is actually validated. They are the right set of steps to take to solve a problem. Let's go back. Let's go to the first agent. It's the simplest of the series. This uses a special prompting technique which is called chain of thought. So we tell an LLM to think first or to think step by step. Before giving you an answer, before giving you a quick answer, it breaks, it tries to understand what you are asking for, and then it generates an answer for you, right? So if you write a prompt for ChatGPT or Gemini or anything, just write think step by step, and then this will be a kind of chain of thought prompting. Your LLM will not arrive at a quick answer. It will think, it will spend more CPU cycles or GPU cycles before arriving at your answer. Here's an example. I have if there are three apples and you eat one, how many are left? So it is trying to reason out. There are three apples initially. I eat one, so I have to do a subtraction, 3 - 1. So I have to give a final answer. Here is a chain of thought. First thought, then second thought, then third thought, and you arrive at the final answer. Right? This is COT agent. The a little advanced than COT is a react agent, reasoning and acting agent. Now COT agent could reason, it could generate a set of reasoning thoughts, but it couldn't take an action except a trivial action like calculating. But a reasoning agent can actually call tools and perform actions. So what does a react agent do? As soon as it receives an input, a query or a task or a goal from a user, it starts reasoning it by understanding what the user wants. Then it generates the sub steps. And for each sub step, it figures out what tools it has available and which will be the most suitable tool to do that. For example, I told Comet to find out the cheapest flight for me. And it saw that finding a flight means it has to search on the web which platforms provide flight information and which platforms allow to book flights. It had to search the web, which means it had to either call Google search or Bing search or any other search. It had to call that website. And once it had searched through the web, it went to makemytrip.com. It had to have the facility, the permission to, select the dates, select the destination and source and everything. And finally, I did not give it my wallet to make payment. Otherwise, it would have done that also. So it is an example of a React agent. It understands my prompt, it reasons out what it needs to do, and it makes a plan, a sequence of actions it should take. Then it takes those actions and it comes back to me and gives the answer. You will often find React agents as browser automation agents or actions, the agents which perform web-based actions for you. So here, this is a classic example from the original React paper. The task that user gave to it is that you are in the middle of a room, you are looking around and you see a cabinet which is marked 6, a cabinet which is marked 1, a coffee machine marked 1, a countertop marked 3, a stove burner marked 1, and a toaster marked 1. Your task is to put pepper shaker on the drawer. So you are describing the environment to the agent. You are telling it what is around it and how does it identify that. And then you are giving it a task. Put the pepper shaker on a drawer, right? And here is on the right hand side how the React agent goes and solves this problem. It's first thinking, right? I need to find the pepper shaker. It's likely to appear in cabinets 1 to 6 or on countertops. Then it goes to cabinet 1. There's a vase, right? Then it goes to countertop 3 and it sees an apple and all that and a pepper shaker also. From countertop 3, it takes the pepper shaker, right? You pick up the pepper shaker. Now again, it's thinking, you have found the pepper shaker 1. What should I do? I should go to drawer 1. Drawer 1 is closed, so I should open it. Now that I have opened it, I can put pepper shaker on top of it. And now the task is over, right? Finally, you can tell the user your task is done. If this agent is connected to a robotic arm, it will actually pick up the pepper shaker and put it in its right place, right? This is the reasoning going on in the robot's mind. It's only that now you have to put or embed this code inside a robot, and the robot will do the task for you. So this is the loop that happens inside a React agent. There's a user, AI or human, who submits a task. The task is given to the LLM. LLM generates the reasoning traces and also the plans. According to the plan, the sequence of actions that are required to be taken, it makes calls to the tools available. And these tool calls return it a result, a feedback. Based on that feedback, the LLM takes next action, or it can sometimes choose a different set of actions. Suppose in the previous case, we saw that the drawer was closed. So it had to first open the drawer instead of directly picking up the pepper shaker from the drawer. So this is the React agent. Here's another example of a React agent. This is my query to Gemini. I'm asking it who is the current president of Uruguay, and it is thinking, right? I have to identify who is the present leader. So it initiated a Google search. This is a tool call. It called Google search and found out the information. Once it found it searched through the Google, it is ascertaining. Ascertaining means it's making sure, it's verifying or validating that this person actually is the president in 2025. And once it has made sure, it has validated its search, it is concluding, it's finalizing its answer. And here is your final answer. Yamandu or IC is the president of Uruguay currently. So this is React agents loop. You give it a task, it will reason out, it will plan, it will take actions, it will validate its actions, then it will conclude and give you back the final result. The next architecture, which is a little more complicated, little more functional than the previous one, is reflection architecture. Reflection means to think back, to introvert. I mean, to do some self-analysis. So this is a self-improving agent architecture. It adds the ability to learn from failures to the previous architecture. So it remembers when it went wrong. It tries to analyze what exactly did it do wrong. And in next step, in next sequence of actions, it tries to take a different set of actions so that it doesn't again meet with a failure. So this reflection architecture basically is an adaptive agent. Here's what the agent's loop looks like. You give it a task. It attempts that task by following reasoning and acting paradigm. If this task is successful, then okay, it stops. But if this task is not successful, it will initiate a new chain, new thread. It will again think, again try to learn from new data or experiences or users' inputs, and it will try to solve your task or solve your problem one more time. The next architecture is AutoGPT architecture. Now, AutoGPT architecture is not an agent architecture as such, but it's a platform or a framework for constructing an autonomous agent. Again, AutoGPT has a reflection mechanism also. It has React facilities, reactabilities also, and it can help you achieve a goal. The way it works is it receives a goal, it plans or generates the sequence of actions it needs to take, then it executes those agent actions, evaluates, and finally continues the loop after reflection, after self-improvement, and so on. So it has these components. The AutoGPT architecture was made by OpenAI, and the LLM it used was GPT-4. It had a goal handler, then a task manager or an orchestrator. It had memory, it had tool executor, and a feedback mechanism. The next architecture we have is a tool former. Now, tool former is an agent which has a lot of tools available to it, and it is very effective in using the tools. Here's an example. You are a helpful assistant, and you have a calculator tool, or you have any particular tool that you want. So whenever you need to use the tool, format that call is like this calculator expression. So I'm giving it an expression here. What is 34 multiplied by 19? It is showing me the result like this. The result of 34 multiplied by 19 is this expression. It has invoked the calculator tool, right? Again, I'm asking it a question and it will show me where it needs to invoke the calculator tool. This example here that I have given to it is called a one-shot example. It's a way of telling your model how you want the output to be formatted and generated. So here, it first calculates the total cost of three elements by multiplying the value by 3, and then it subtracts the discount for this query, and then it gives me the final answer. And the final architecture is Voyager architecture. Voyager framework is used in gaming scenarios. So Voyager was made for playing Minecraft, which is a very popular game. So this Voyager continuously learns from the game environment and it keeps on writing Python functions. Those Python functions are called skills. It keeps on building a library of skills for itself. And it has a curriculum agent which sets new goals for it based on what is the current situation of the game and everything. It has a code executor which helps it to write Python code, fix that code, and reattempt new moves. Of course, the goal is to win the Minecraft game. It also has a module for self-improvement where it monitors which code is failing, what bugs are coming. It asks ChatGPT to revise that code, and all of this is the final goal is to win the game. As the loop that looks like for Voyager, it sets a goal. It really retrieves relevant skills. By skills, I mean the Python functions from its skills library. Then, based on those skills, it can ask GPT-4 to generate more code, executes that code, in a way it plays the Minecraft game, observes its results, and determines whether I'm winning or not. If it's failing, then it will update its skills, it will refine or debug its code, and repeat another time. So you'll see on screens a poll. You can participate by either scanning this QR code or going to slido.com and entering this number. Would you be kind enough to participate? Which agent architecture sounds most useful to you for solving most complex problems out of React, chain of thought, and reflection? Can you see the poll displayed? Yeah. But don't you think reflection will be a better one? Yeah. Reflection will be more successful in solving more complex problems, because as we humans also observe that while solving complex problems we often have to backtrack and do something else, undo what we have done, unlearn what we have learned, and use a different method, follow a different action sequence. So reflection helps when you are about to solve a more complex, more multi-step problem. Right? Almost everyone has got that correct. Reflection is more suitable when you have more complex problems to solve. So, what are the ways in which an LLM can control an application? LLM can be a router where it chooses between two potential application paths, right? It's like an if-else statement. If this is true, then do this, otherwise do this. In second case, LLM can be an orchestrator. That means it has many paths to select, it has many tools available, and it has to choose which one to use at a particular moment in agent's life. The third possibility is where LLM is a judge. It evaluates whether the answer, whether the action I have taken previously is correct or is sufficient or not. So LLM can be a router, it can be an orchestrator, or it can be a judge inside an agent. This is when LLM is a router, right? So it is just making a choice between two possible routes, path one and path two. A tool calling agent is an agent which has multiple tools available to it, and the LLM acts like a router and makes a choice of which tool to use at any point in agent's life or trajectory. There are other architectures, for example, human in the loop, where the agent's loop consists of a fixed point where human is required to give an input. And there are multi-system agents, multi-agent architectures, where there is a lot of concurrent processing. All of them are working parallelly, collaborating with each other, which we will see in later sessions. There are 5 levels of autonomy in the agents. Level 1 is there is almost there's very little autonomy. User is in control. You give agent the input, you control which actions it takes and everything. Level 2 is where you, a human, are just a collaborator. You choose, some actions. The agent, the LLM chooses some actions and decisions. Both of you are equally responsible for planning, delegation, and execution of tasks. Agent may not always follow you, and you may not always let agent take the action it has chosen. The higher level of autonomy is when you are just a consultant. You ask something or you suggest something, but the planning and execution is completely the domain of the agent. Level 4 is where you are not even a consultant, you are just an approver. The agent decides what to do, does it, and you just have to finally approve whether it is correct or not. Or suppose you want to go and make a payment, you can provide your API key, or you can log in into your wallet and make the payment. And on top of this is the level 5 where it is fully autonomous. You're not even required to enter the keys and log into your Google Pay account to make the payment. Even that is taken care of by the agent. So level 1 is the smallest autonomy, the lowest level of autonomy, and level 5 is a fully autonomous agent. Then there is agentic AI. That there's a confusion many times. What is an AI agent and what is agentic AI? So AI agent is one software system. And agentic AI is a paradigm, like object-oriented programming is a paradigm of making software. Agentic AI is a paradigm of designing software, where the software is consisting of one agent or multiple agents. Right. So in addition to all of this, there are agents which work in background. They are called autonomous, fully autonomous agents. There are agents which are interactive. You have to give them input like conversational AI bots. Then there are agentic systems where there's a single agent or there are multiple agents working in collaboration. There are many case studies. You can use them in finance, you can use them in medicine, you can use them in web browsing, you can use them for scientific research, you can use them for coding and all that. I've chosen some case studies like which we normally do not expect. This is a scientific discovery agent. It has discovered new chemical compounds. It has used the LLM, which is trained on chemistry and all that, and then it can discover new molecules in chemistry for you. Here's a paper if you wish, you can check it out. Then this is a very interesting use case for multi-agent architecture. It is simulating a human being, how a human agent will work and survive in its environment, right? How will it wake up? Then what will it do? How will it interact with the family and all that? So it's generated this entire setup is actually simulating a human being. We saw the Comet browser already. In tomorrow's session, we will be working hands-on with coding agents like Gemini and Windsurf. So these are use cases for AI agents. Here's a new poll for you. What is the most exciting potential use case for an AI agent in your specific situation? What would you like an AI agent uh, to do for you? Your repetitive tasks, automation, or it should help you in your research, or it should help you just for, writing reports, generating memes and images and creative writing, generating Ghibli style images and all that. That's nice. So as a case study, we will also be looking at a research agent in one of the upcoming sessions. So around 54, 56. Right. Around about 54 to 56% people want an AI agent to help them with their research and information management, which is great. So we'll be looking more on this kind of agents. With that, I think we have reached end of, we have already overstepped the time by 5 minutes. I would appreciate if we can take the questions either tomorrow or on my personal DM after 8 p.m. if that is okay with everybody. Thank you everyone for joining me today, and I'm looking for a very interesting session tomorrow and post that as well. Thanks a lot for being here. I will share the slides and everything after this camp is over. Right? Thank you very much for your time.
One question. Hello.
Yes, madam.